Good morning. Today we're going to talk about CS291A Project 2. In Project 2, you'll be working with Docker, Sinatra, and Google Cloud Run. Sinatra is essentially a simple a simple Ruby web framework that makes it pretty straightforward to write an API endpoint and make requests against it. Much simpler than Rails, hence why we're using it for this particular project. A lot more lightweight. Docker is a container orchestration service. What it essentially allows you to do is run an operating system essentially within your operating system if your primary operating system supports containerization. For example, if you're running Linux, and I believe Mac OS X now natively supports containerization, so you can install Docker for those, and then when a process runs inside of a container, it's actually running in your operating system, but it's restricted, has a restricted set of permissions, so it shouldn't be able to break out of its control group. It's different than virtualization in that with virtualization, you're actually virtualizing an entire machine, whereas this is not doing it. It's running the commands on your own machine, but you have the file system and package level isolation within the container. It's been used for the last handful of years pretty extensively. It makes it really easy to share environments that are more lightweight than running a whole VM. If I'm not mistaken, when Docker runs on Windows, for example, a Linux kernel VM that supports containerization is actually started up and then Docker runs inside of that VM because Unix type processes apparently can't easily run on top of Windows. Maybe that's changed, but that's my understanding. Google Cloud Run is a technology that allows you to run containers in response to a web request, and not just run a container, but actually pass through the HTTP request into the container. So it's different from AWS Lambda because Lambda supports certain frameworks like Ruby or Python or Java or Node, and there's a specific way that your code has to be written to be able to be entered into. With Google Cloud Run, you can run anything as long as the container has a port that it's listening to when it starts up within a certain amount of time. Then it'll automatically pass all that information into that port. And it acts just like a running web server, essentially. So they're a little bit different. Cost-wise, Google Cloud Run, if I'm not mistaken, is about 2 times the cost per request, but it gives you the flexibility of being able to run your own containers, which are a little bit easier to set up and deploy than managing the deployment for AWS Lambda. Also, AWS Lambda isn't really, web requests aren't a first-class concept of Lambda. In order for web requests to work, you have to associate your Lambda with an API gateway, which we didn't really talk about before. Whereas Google Cloud Run is specifically meant for web requests. And it's you actually need a third-party thing if you want to run it as an asynchronous job because it needs a web request behind it. Okay, so the service that you're going to be writing is essentially a REST-based service on top of Google Cloud Storage. So you're going to write an API that allows people to list files, create files, or upload files, fetch those files, and delete those files. There's not going to be a concept of update, but we could have implemented that. And what you'll get is the experience of working with a simple Sinatra application. So a little more than just writing function code. You get a little bit of framework support this time on top of Ruby. You'll get to work with Docker containers. So the nice thing is that you'll be able to essentially fully test your application locally before deploying it to Google Cloud Run. You can do both, but if you have your Docker environment set up without needing to install any specific tools on your own machine other than Python maybe, uh, you can test against this application. And it should respond in the same way that it would be when you push it to Google Cloud Run, which is fantastic. Doing that setup for AWS Lambda is a little bit trickier because you need a Lambda-like environment, which you can get through Docker as well. But there's a big benefit there. You will still need to access Google Cloud Storage, whether you run it locally on Google Cloud Run. So we'll walk through getting set up for that. So you'll be able to perform these actions, the learning outcomes, with Google Cloud Storage. You'll have written a Sinatra web application that has 4 API endpoints. You'll have built a Docker container. You're not going to go through the process of manually creating it. I'll explain what's in it. You'll deploy this code to Google Cloud Run successfully, which is actually it's fairly straightforward. And then you will do a comparison of how Google Cloud Run behaves to that of AWS Lambda. What you should find is that Lambda performs better, but again, they have different goals, so it's not immediately fair to compare both. This project is due next Tuesday before 11, and this video will be posted on YouTube. I will create the project submission probably tomorrow, Wednesday. So let's go over the API specification. You're going to implement 4 primary endpoints and 1 redirect endpoint. So get slash is just going to redirect to slash files. We haven't done any redirects yet in this class, so here's an example. This time I've posted the command. So I did all of my testing with curl before I wrote the verification script. So I'm providing examples of you can run this curl command, assuming you have curl installed, to invoke this endpoint. And then here's an example of the relevant parts of the response. I removed the unnecessary headers. So that's get slash. Get slash files should return a JSON list of files. So if I do curl-d, this outputs the headers to standard out. That's what this argument does. It should respond 200 OK. And the list of files, we'll talk about this, but all the files should be referred to by a SHA-256 hex digest. So each file should appear in this JSON list, and they should be in sorted order. So numbers come before letters, and they all should be 64 characters long. Also, technically, hex digests can have capitals in them. However, and you should allow them to be input that way, but when you're displaying them, always work with lowercase for consistency. That's get files. Post files is how you create a file or upload a file. So there's a couple of things here. Well, on success, it should respond with 201 created, and the JSON body should look like this. So it's a dictionary or a hash that has the key uploaded, and then the value is the SHA-256 hex digest of the uploaded file. So that's what this response may look like. You can create and upload a file this way. This file part here, this F, is curl's way of saying upload this file using a multi-part content encoding. This particular parameter is what that name of that parameter field is. So if we had an HTML form with a file input, we would name that file input. We would give it the name file. This could be something else, but my test expect it to be file, nothing else. If the file has already been uploaded, and it doesn't matter what the file name is, but if any file that has the exact same contents based on its SHA-256 hex digest, you should return a 409 conflict. If the user is calling post files without a file parameter as a file, then 422. Or if the file is more than 1 megabyte in size, it should also 422. Get files digest. So remember that this is the hex digest. So if I pass this hex digest back into the path, so I put it as part of the path, that's a REST resource for give me that one item. So on success, respond with 200. The content type header, so when curl uploads a file, it does some detection of what is the content type of this particular file. And it does it kind of naively based on the extension. So this should be a text plain file. So the content type header should return the file as it was, the content type as it was uploaded. What you may note is if you upload with text plain, any text types, this charset UTF-8 gets appended by Google Cloud Storage when you pass the MIME type into Google Cloud Storage. That's okay, and my tests account for that. The body of the request should contain the contents of the file in the 200 case. If there is no file corresponding to the digest part, so when you try to look it up, it doesn't exist, respond 404. And if digest that's passed in is not a valid SHA-256 digest, then 422 for a bad request or unprocessable entity. So the curl command looks like this. This is the one for the file that was just uploaded. And the response should be okay. It has the content type set. You don't necessarily need to set this header, the content disposition header, but this is kind of convenient. It'll set this up to automatically download if a browser opened this file up, and it would prompt to save with this particular file name. Otherwise, it'll guess the file name based on the path of the load resource, which I think would actually be the same in this particular case. And this is the contents of the file. It's called test file, and you'll see later how we created this file. Delete files digest is very similar to get, other than this time we're deleting the file. So in this particular case, there's no 404, and I'll talk about that. If the digest is not a valid hex digest, return 422, similar to get. But in all other cases, whether or not the file existed, respond 200. Recall that HTTP delete should be an idempotent operation as per specification. So even if the file doesn't exist, I want to make sure when I call delete files digest that no file exists at that resource. I don't care if it doesn't already exist. So as a result, we're always going to return 200 okay. So if you call delete more than once, it should still be okay. Of course, it should actually delete the resource if the resource exists. So that's the API specification and the endpoints that you will be implementing. Because we're using Google Cloud Storage, everyone is going to use the same bucket. So we're all going to be adding and removing files through our Google Cloud Run service or through our own Sinatra apps. But it's the same shared resource behind the scenes. So to make sure everyone is putting files in that Google Cloud Run or in Google Cloud Storage in the same way, I have some specification. So you'll have access to this bucket, CS291_project2 in Google Cloud Storage. The project ID that you'll need is CS291F19. And here's example Ruby code to get an instance of the bucket. So this gem Google Cloud Storage is already going to be prepared in your Docker container for you, or in your Docker container for you. And so we create an instance of the storage class using the project ID, and then we get a bucket. Now, normally without this argument, it's going to call a lookup to get info about that bucket, but your account doesn't have permissions to call get bucket because they aren't necessary. So we skip the lookup, which means we don't actually do an HTTP request here, but you'll still be able to interact with this bucket by downloading files, listing files, and creating files. And you'll have to look at the Google Cloud Storage documentation for what the operations are on the bucket class so that you can accomplish that. When you save a file, so remember we're uploading a file, and it's going to have a file name, but we're going to completely ignore that. When you upload a file, you should compute the SHA-256 hash of that particular file, and then save it. So for example, let's say I create a file, test file, and then just to show you, this is on OSX, SHA-256 sum test.txt. This is the SHA-256 sum. The way we want to store them in Google Cloud Run is to extract the first two-digit prefixes and make those essentially like directories. Google Cloud Run doesn't really have or Google Cloud Storage doesn't really have a concept of directories, but they can mimic it by using slashes. So we're going to take the first 2 digits, bucketize them, the second 2 digits and bucketize them as well, and then the remaining 60 digits are the rest of the SHA sum. So you're going to store them in this particular manner. Also, please make sure to keep them lowercase. Ruby's library for computing SHA-256 sums should do that for you, but just do that. So we're going to separate those out, and then you can fetch them that way, and then that way everyone will be consistent. I have thrown a couple files in that bucket which don't meet this syntax, so when you list files, or called get files, don't show those other ones. Only show ones that are valid SHA-256 URLs that match this storage requirement. So you'll have to come up with some way to figure that out. Okay, so that's the project in a nutshell. Let's actually look at deploying this project. So there's the project template, and as per usual, we have a verification script. And there's some other, like you'll be using Docker, Google Cloud Run, Google Cloud Storage, Ruby, Sinatra. And you'll need to install Google Cloud Tools, and there's a quick start on Google Cloud Run. If you want to see how to do this from scratch, this is kind of a useful resource. Yeah, and you can see like you can do it in different languages. We're working with Ruby. Okay, the verification script exists here. I'll just open that up for now. Here's the template. So you will want to either use this template or clone it. I prefer you don't clone it because then if you push your changes, everyone will be able to see them. So preferably use this template. And yeah, so that way it's not linked to this. Okay, there's a few things in order to get running on this project that you'll need to set up. So one, all of the commands below refer to this environment variable CS291A account so that you don't have to update the command every time. I encourage you to set this variable. So you can either do it per session, but then every time you open a new terminal, you have to run it again, or you can add it to your like bash profile or similar way, somehow get it into your environment. You will need to install the gcloud tool so that you can run the gcloud commands. So there should be instructions here for various systems. So get that set up, and when that's set up, you should be able to run gcloud auth login. When you log in, select if you're logged into, like, say, your Gmail account and your UCSB G Suite account. Make sure you select your UCSB account because that's the account that has the permissions to access our Google Cloud project. You can verify that the above works, that you're logged in by running gcloud projects describe. And it should give you this particular information. If that doesn't work, then you're not likely authenticated correctly. So make sure that you get this working before proceeding. Then, in order to successfully run or access Google Cloud Storage when you have a local Docker container, we need to create this application default file. So run this particular file, and then that will create a specific file that gets copied into the container. In order to publish or push your Docker containers to the Google Cloud Container Registry, we need to run gcloud auth configure docker. Of course, before you do that, you need to install Docker. So the link here should give you instructions to install Docker. Then we configure Docker. And then we actually get into, so those are the setups. And now we can talk about how do you develop this locally. So let's actually take a look at the project before we actually build this. So this is the template for what it looks like. And I'm going to open up this in Sublime. So we have the Docker file. So a Docker file is a specification for how to build the container. And Docker is great because it's built around this concept of layers. So this from Ruby 2.6 actually uses a container that's already built, the Ruby container version 2.6 or tag 2.6, and I get all of the things that are pre-configured there. So why don't we just take a look at that. So when Docker is running, or when I have Docker installed, I'm going to do Docker images to see the list of images I have. I have a bunch of them here. But let's say I want to run this Ruby image directly. Like, let's just say I want to run a Ruby environment. So I can do Docker run IT. I is interactive. T is use TTY. I'm going to do remove so that this way the container is cleaned up automatically after I stop it. And then I need to tell it I want to run Ruby 2.6. And then I tell it what command to run inside of it. So I'm going to do bin bash, assuming it has bash. And it would download that container if I didn't have it, and then it starts up. And what I can see is that there is Ruby 2.6 installed. And then I can Command D to kill it. Let's say I wanted Ruby 2.4. Let's see if this works. So it doesn't find it locally, so it has to pull it. So it's downloading this image. Note that some of the things already exist because they use layers. So these first layers already existed, so it only needed to pull 2 layers. And now if I run this, I'm already running this image. So now if I do Ruby -- version, now I have Ruby 2.4. I didn't have to set up anything. I didn't have to configure any environments. In this particular container, I have this particular environment. Similarly, I could pull Python. Let's pull Python 3.6. This should work, so I don't have it locally. Some of these layers exist because they're shared layers, or maybe I already had them. And then I have version Python 3.6.9. So this is the beauty of Docker, is I can get this environment, I can work with it, I can run stuff immediately. I can set it up to run commands in the background. It's really, really powerful, really, really useful. And it's just great to quickly get these isolated environments. Okay, so that is from Ruby 2.6, gives me that layer that has Ruby 2.6, and then I'm going to add some new layers. Each command is a layer on top of it. So this, again, this file specifies how do I build the container that I want to build. So for Ruby, I need to specify the bundler version that matches the one in Gemfile. So I'm telling it use bundler version 202. Workdir app says all of the commands that I'm going to run, like copy and run, should operate within the /app directory. I'm going to copy into my container build environment from my local directory the gem file and gemfile.lock. So these are specifications for Ruby, and you'll use this in your Rails project, that say what packages are needed. So the three packages are Google Cloud Storage, Puma, and Sinatra. And I've pre-built gemfile.lock so that you don't have to have a Ruby environment. But the way I did that is run bundle or bundle install, and nothing changed here. Basically, when you run bundle install, it generates gemfile.lock in addition to installing locally the gems, but you don't need a copy of the gems installed locally because they'll be installed into your container. Yeah, this gemfile.lock says bundled with bundler 202, and so that's why we need to have bundle version 202 here. If there's a mismatch, there can be problems. So I'm going to copy these two files into the container, into the app directory. And then I need to actually prepare the container, the Ruby environment in the container. So I run gem install bundler. This gives me the right version of bundler. And then I can do bundle config global frozen 1. This ensures that it doesn't try to update anything in gemfile.lock. It only uses what's there. And then I run bundle install. That installs these Ruby gems. So I only specified 3 gems, if I look at the gem file. But each of these gems may have their own list of dependencies, which is why you can see like addressable requires public suffix. Google API client requires these gems, and it locks specific versions so you get a consistent environment. And if we find the gems I actually wanted to install, like Sinatra requires Musterman, rack protection, and tilt. Google Cloud Storage requires these gems. And what was the other one? Puma. Oh yeah. What does Puma require? Puma requires NOR. No NIO4R. Okay. So Docker file. So it prepares the gems in Ruby for the Ruby environment, and then I copy my the necessary files to start the application server. Now note, I am not running, I could run, but I am not running a standalone HTTP server. Puma is going to be our application server, but it's also doubling as the HTTP server. The reason for this is Google Cloud Run will filter out many requests and do some rate limiting. So I find it's not as necessary. But there are still some weird cases that can get through to Puma that I actually discovered in testing. So for real production case, I'd still recommend maybe throwing Nginx in front of it. But for simplicity, we're not going to do that. So we're going to copy these 3 files. app.rb is our actual application. Config.ru specifies how we are going to start this application. So it requires /app. This is for, RU is for rackup. So remember that rack was installed as a dependency. So this will say load the app and then run Sinatra application. I actually don't know if this file is needed anymore. Maybe I left it here. You could try removing it, but we're going to leave it. And then we have puma.rb, which says the Puma environment should listen on port passed in as env port. This is a specification of Google Cloud Run. They have a known port, but they say it's subject to change. So it needs to be passed in as env port. If this environment variable is not set, then run on port 3000. And I'm telling the application server to listen with up to 80 threads, a minimum of 80 and a maximum of 80. The reason I'm doing this is Google Cloud Run will deliver up to a maximum of 80 concurrent requests if you ask for it to one particular container. So I want to make sure we can handle that. This may, for this application, overload the application, and that's for you to measure, and you can play with these settings if you want to try something else. So that copies these files in. We'll look at app.rb momentarily. And then when this container is run without given a specific command, so by default, it's going to run bundle exec puma-c puma.rb. So this bundle exec may not be necessary, but this is the standard way to use the environment that was bundle installed. So it's going to invoke the puma command and say puma should start with the configuration that's provided in puma.rb. And actually the rackup is definitely needed because otherwise it wouldn't know to load app and then run Sinatra application. So that's how it is built. This command only runs when you actually start the container. Otherwise, everything else is done building the container. So let's build the container. So we have develop locally, Docker build. This -t is the tag. This is what I want to name my container. The reason why we're using this URL looking tag is because this is the format it needs to be in to push it to Google. We can give it a shorter tag, but then we'd have to re-tag it or add an additional tag before we push to Google. So we might as well just deal with that. So I need to make sure I export my account name because I don't have it in my profile. And then I'm going to do build. And it'll show you the steps. Now this is really fast for me because you'll note that many of these steps already ran. So see how it says using cache. Well, the great thing is if you don't change any parts of your Docker file, then most of these things can come from the cache. But if I change app.rb, it'll cache up to this point, and then it'll only rerun these two commands. If I change my gem file, which is copied here, then it has to rerun this command because it'll notice a change in this particular file. So I build the container, and then I can run it locally. So this is similar to the run I showed before with a few additions. So I have -it remove. So remember interactive tty, remove the container so when I'm done using it. The -p says forward local port 3000 to container port 3000. So that's the port inside the container it's going to listen on. This allows me to talk to the application locally. If I don't bind this, then there's no way for my host operating system, there's no easy way to talk to the container port. -v sets up a volume for one particular file, and this is how we have permission to access Google Cloud Run. So this is tied into this application defaults. When you run this command, it should create this file. Now note, if you're on Windows, this path is going to be wrong, so you'll have to fix this path to wherever this application default credentials file is in order to get this command to work. On the remote side, it needs to be put in this particular location to work. And if you're not familiar, these slashes at the end of the line just say this command continues on another line, so it's not one long line. And then I tell it the tag to run, and that's the tag we gave it. And note this time I don't have bin bash on it because I want it to invoke the default command that's specified in the Docker file. So we run this, and you'll see that it says Puma starting in single mode. Single mode means it only has one process, but it has up to 80 threads. It's in development environment by default. We'll change that when we go to Google Cloud Run to production. And it's listening on 3000 internally. But remember, we mapped localhost. So now, let's, actually I'm going to open up tmux real quick. And then I'm going to run this. Okay. And then I'm going to separate this. And so I can do curl -d localhost / oops, I need to make sure I specify the port. And we get 200 OK hello world. We actually haven't looked at the application. So if we open up the application, it's a very simple Sinatra application that defines a get for / and then it returns hello world. And by default, if you return a body, it'll respond with a 200. So this is the beauty of Sinatra. This is a really simple application. If I wanted to do post to slash, I can define post do, and let's log locally, and let's output, what is it called? I forget what it's called. Well, we can output the request. And actually, let's make it a little bit easier to work with. So I'm going to do require prettyprint request. I think this will give us some useful information. And then let's just return post. Okay, so we're going to make a change, and we can stop our container. You have to rebuild it. Oops. Oh, that's interesting. Okay. Did I not build? Oh, I built before tmux. Okay. Let me copy the build command. I have all my history, but not the one specific that I just ran. When I open up tmux, it doesn't use the previous history. So I'm going to build, and then we're going to run again. So this is a process. If you want to change the application, you have to build and run. You can link these commands together so you don't have to do them both. Note that it condensed it all into one line. So now it's listening again. So I can do my curl command. That's great. Let's say I want to hit the post endpoint. So I can do x post. And so it responds with post, but then we get some logging coming into Puma's log, which output to standard out by default. And so we see some information here about the request. And so we have like rack version, script name, query string, request method, server name, remote address. So you can look at the Sinatra application to see what variables are supported. So request is a method that exists in Sinatra. There are other ones to get additional variables, like the post body or the post parameters. I don't think it's called params. I don't remember what it's called. But this is all the information about the particular request. Maybe it is called params. Anyways, so that's information. That's how you can modify the app and run it locally. So great, we can run it locally, we can curl it, and work from there. Let's continue on. So run locally. Here's the test. I showed you how to do that. And it should provide output like this. Great. So now let's say we want to do a production deployment. So anytime you want to update or create your production deployment, you first need to push your container. So anytime the container changes, we push it. You should have permission to do this. Note that it says like these layers already exist, so the only thing I've changed is the uppermost layer. So it's pushing, and then it creates a new digest for that particular layer. And then we're going to deploy it to Google Cloud Run, which you have permission to do. So again, you need to have gcloud installed. And so Google Cloud Run is technically in beta, so that's a beta command. I'll go through these. So allow unauthenticated. By default, Google Cloud Run is not like publicly available, the URLs, so you need to have a token to access them, similar to what you did in Project 2 or Project 1. But allow unauthenticated means you don't need any tokens to deal with. Concurrency 80 says allow each container to handle up to 80 requests. Image is a link to the tag that you push to Google Container Repository. Memory, I've just set this to use a little bit less memory. You can use up to 2 gigabytes, but you shouldn't need to. Platform Manage says use Google's hosted service for this. So Google Cloud Run containers run on top of Kubernetes. You could host your own Kubernetes cluster on Google Cloud and then tell it to use that, but for simplicity, we are not. Project specifies what project this should be part of. You can create multiple Google Cloud projects. So this is the name of this particular project, or the ID of it. We're going to be deploying into the US Central 1 region, which is Iowa, because that is the closest region to us that supports Google Cloud Run. The service account is interesting. So Google Cloud Run does not run containers with your set of permissions. It takes on a service account and runs with the permissions of the service account. So I've already set up this service account to have permission to create, delete, list files in that particular bucket. So it has fewer permissions than your account, because this service account doesn't need permission to create other Google Cloud Run projects, for example. So that's the beauty of the service accounts. And then we're going to pass an environment variable into the container when it runs, which says rack env production. So this switches to production mode so that it won't log to the browser particular errors. You'll get that login when you run locally, so you should do all of your development locally. But when you finally deploy, you should be in production mode. And then this will be the name of your service, is why we're using that variable. If, I thought I mentioned this somewhere, but I guess I didn't. Or maybe it's up here. Oh yeah. If your account name has an underscore in it, replace it with a hyphen, or just delete the hyphen. The account name isn't too important this time. I haven't, you can, but make sure your account name, actually use your account name, because that's how I'll figure out which one is yours. So use your account name. When this deploy runs, as we saw, no, we didn't run this. You'll get an output that tells you where it's running. So we will run this. And so this is creating a revision, deploying, setting a policy for the service, and then it will come back with this revision has been deployed, is serving 100% of traffic on this particular URL. So we could go to that URL and we should get hello world. It takes a couple seconds for it to spin up the first time, because it has to spin up a container, but then subsequent ones should be faster. And remember, I can post to other areas. So let's use this URL, and then let's find the logs. So rather than using my localhost 3000, I can post to that application on slash. And what did we get? Length is required. Okay, so this is Google Cloud Run server saying I need to send a link. So I can't just post data. So let's actually put a body. And I think that, nope, one. There we go. Okay, so I'm posting a body that contains one post. Okay, so it just tells me post. I didn't respond with any information, but that information should be in the logs. So when we look at the project description, it says you can view the logs. So you click on this link, this will take you to the application. You may need to change your account. So I'm logged in as my CS account. But if that's not your primary account, it may say you don't have permission to access this. And that's probably because it's trying to access this project with your Gmail account, for example. So use this button to switch into your other account. I'm going to refresh this page just to see if anything updated. Okay, so we have our thing, and I'm going to click on our service that has my account name. Similar to what you're seeing here, I haven't yet figured out how to get these stats to show up to give the permissions for that. So don't worry about that. The important part is, like, you can see revisions, the revisions you've deployed, the URL that it's running at. The URL will always be the same. You have one revision. And then the interesting part is the logs. So you'll actually see the useful information we want here. But so this says 50 messages, and this is the output from that particular message. And if I keep scrolling up, it should load the rest of those particular messages. So that's here. And then let's say I want to look for specifically some sort of warning or something. I can change this. So that'll look for anything that's a warning or higher in case you have any request failures. But recall you can do all of your testing locally, so you shouldn't need to do it by pushing here. That's, again, the beauty of containers. What runs here is going to be what runs there. Obviously, we saw the one difference, which is locally I was able to run curl post without any body, but fortunately we get a response back from Google Cloud right away that says length is required. So their server is more particular than Puma's server, and that it's not allowing an HTTP request that doesn't have a length header set. Content link. Okay. So the warnings show all of the non-200 requests, or all of the client error requests. So if I didn't want to see those, I could go outside of warning and go up to error. And I think there might have been there's some logs that log as error, maybe when I was deploying stuff before. Replace node, so I don't know exactly what this is doing. There's some stuff here, but it doesn't seem too useful. So I haven't had any legitimate errors in Google Cloud Run. Okay, so those are the logs. And that's pretty much it. They're logs, resources for the quick start, Google Cloud Storage. So this is going to be the good resource for using Google Cloud Storage. Gives an example of how to retrieve buckets. Well, we have that. But how to retrieve files out of the bucket. How to create a file. So this is useful. You'll also have to look up in Ruby how to compute a SHA-256 sum. If you search for Ruby SHA-256, you should be able to find it. And that is pretty much it. The test script is pretty much the same format as before. It goes through a number of tests, test root URL. The big one is create, get, list, delete. And yeah, I will have a couple of test cases that I can't run here because I can't assume you have the Python environment. But basically, I'll run a test case where I directly put a file into cloud storage in the right format, and then I make sure that that file shows up, because I should be able to put a file out of band, and it should show up in your service. And that just makes sure that you are using the right syntax for the files. And that is all. So happy hacking, good luck with the project, and as always, let us know in Piazza if you have any questions. Great, thank you.